Welcome to this short video looking at how we can measure resistance. Over the course of this video, we will look at how we can carry out an investigation to measure the resistance or look at how the resistance is affected by the length of a piece of wire. So let's have a quick look at some of the equipment we can use. Wires used go and connect things together in the circuit and they conduct the electricity. The cell provides the energy needed to drive the current around the circuit. That can either be plugged into a wall socket or it can be a battery. A ruler is used to measure the length in millimeters. Crocodile clips are used to connect to either end of a cut piece of wire in this experiment. An ammeter is used to measure the current through a component in amps. A voltmeter is used to measure the potential difference across the component in volts. So a control variable is any variable which does not change during the experiment. The dependent variable is the variable that we are going to measure a response to the independent variable. A hypothesis is a prediction on whether the independent variable will have an effect on the dependent variable. An independent variable is a variable that we are changing. An anomaly is a result that does not fit the pattern. A correlation is the relationship between two variables. An error is a measure of the difference between the measured and the calculated value and the true value. And precision and accuracy are often used interchangeably, but in science they have different meanings. So measurements that are close to the known value are said to be accurate, whereas measurements that are close to each other are said to be precise. Now that we've had a look at different variables and things, we can go and look at how we carry out the investigation. So remember, when you put a method together, it needs to be detailed. So if we look at how we can investigate how change in the length of wire changes resistance, we need to think about the equipment that we might use. So some of the equipment that we might use would be an ammeter, a voltmeter, ruler, a length of wire, a cell, and a couple of crocodile clips. So the first step would be to connect up a circuit as shown in the diagram below. Then connect crocodile clips to the resistance wire 100 centimetres apart. You would then record the reading on the ammeter and the voltmeter. Then move one of the crocodile clips closer until they are only 90 centimetres apart. Then record the new readings on the ammeter and voltmeter. And repeat the previous steps, reducing the length of the wire by 10 centimetres each time down to a minimum length of 10 centimetres. You can then use the results to go and work out the resistance using the equation below by rearranging it to voltage divided by current will equal resistance. If we go and put it onto a graph would look something like this. So we can see there that as our length of wire increases in this graph, then the resistance should also increase. So now that we've looked at how to carry out the investigation, there are just a few last things to think about. So, there are a few questions that you should ask yourself when completing your method. So, what thing should you do first? Is there something confusing you? And if there is, where could you look for some help? Could you explain your method to somebody else? So, does it make sense? Could you have used more scientific terms within your method? And if you need help, do you know where to look for it? Have you double checked what you need to include? And have you had a think through how you could possibly make your method better? Right, that's it for now. Thanks for watching, and I hope this has been helpful.